In section 12.1, we discussed exponential equations. Now we're going to discuss logarithmic equations or logarithmic functions. So for x greater than 0 and b greater than 0, but b not equal to 1, if we say y equals log base b of x, that's the same thing as us saying b to the y equals x. So what we have is b is the base, y is the exponent, and x is what that equals. So we sort of swing it this way. Base to the exponent equals that. So base, exponent, and then equals the x. There are two special logarithms for which we use slightly different notations than the one given in that box. And they are the natural log, ln, which is log base e of x. And we talked about e in section 12.1, that is Euler's number. So we don't write log base e, instead we write ln, which again stands for natural log. And if the base on the logarithm is 10, we don't write the base there, we just write log of x. So if you see a plain old log with no base, it means the base is 10. So let's practice writing these in their exponential forms. So we start with the base, which is 7. We raise that to the exponent, which is 3, and that equals x. So there that is written in exponential form. And of course, we could, if we wanted to, evaluate 7 cubed, which is 343, equals x. So those are the same things. Okay, you should pause the video and try number 2 on your own, and then restart the video. So we have 2 equals log base b of 25. That means that b squared equals 25. Now let's practice going back the other direction. So instead of going from a log equation to an exponential equation, we're going to go from an exponential to a log. So we can always start with the base. So that's log base b. What's on the other side of the equal sign goes next, and the exponent on the b is what that equals, what that logarithm equals. Okay, you should pause the video and do number 4. Remember that when we have a log base e, that it's one of those logarithms which we use a slightly different notation for. Okay, if you've tried that, we have the natural log of 33 equals the exponent on the e. And remember, ln, natural log, is just another way of saying logarithm base e. So let's look at some basic properties of logarithms now. The log base b of b always equals 1. That makes sense because if we turn that into an exponential function, or equation, sorry, we say that b to the first power equals b, because we never write the exponent when it's a 1. Okay, log base b of 1 is 0. That makes sense because if we turn that into an exponential equation, we have b to the 0 power, and that equals 1. If you recall back when we went over the rules of exponents, anything to the 0 power is 1. And the other thing we have is log base b of b to the x is x. That also makes sense because if we turn it back into an exponential equation, we have b, the base, raised to the x power, and that, of course, equals b to the x. So let's use those 3 rules to practice doing some problems without using our calculators. So we have log 1000 and we want to know what that equals. Well, remember, when we have a logarithm with no written base, that means that we have a log base 10. So log base 10, now the question is, we have property number 3. Can we rewrite 1000 as a power of 10? Yes, we can. It's 10 cubed. And so by property number 3, that has to equal 3. So the log of 1000 equals 3. Okay, why don't you look at 2, 3, and 4 on your own and see if you can use those 3 basic logarithmic properties to do them. Pause the video, and when you're done, restart and you can see if you got them right. So number 2 says log base 1/5 of 1, and we want to know what that equals. Well, don't be scared by the fact that the base is a fraction, because property 2 says that any log base anything of 1 is 0. So that's just going to be 0. Okay, on number 3, we have a log base 3 of a number. So that's not 3. So I think that indicates that we're going to be using property 3 again. So can we rewrite 27 as 3 raised to some power? Well, yes, we can. 27 is 3 cubed. And by property number 3, that has to equal the exponent of 3. So log base 3 of 27 is 3. Okay, number 4 seems a little scary because 243 is a pretty big number. But since the base and the argument 243 are both the same number, we're just using property 1. So the log base 243 of 243 is just 1. So we'll end this video here, and in the next video, we'll do some graphing.